Hello everyone, my name is Liam Bryan and I'll be taking you through my research and design project, which explores beach safety, movement infrastructure and a proposed architectural intervention along the False Bay coastline. The safety map. My project began with a series of initial site visits and mapping exercises. Through these I became aware of a recurring theme, water and beach safety, especially how local knowledge, often intangible and unspoken, is not accessible to new beach users. The safety map started as a way of capturing these layers of understanding. It looks at different aspects of safety across the beach, but it soon became clear that I needed to scale in more closely to understand the nuances of the site. The summer map. In the summer season, Surfers Corner becomes intensely populated, particularly with swimmers. Lifeguards are on duty and the beach is highly activated. By overlaying multiple images of the site, I trace patterns of movement and areas where people tend to gather. From this, certain zones of unsafety emerged, often where visibility from lifeguard towers drops or where people drift towards the rocks. These areas become critical points of focus. The winter map. The winter map reveals almost the opposite condition. The beach shifts from swimmers to predominantly surfers and typical activity zones change. However, in winter, the lifeguards are no longer on duty and the flay mouth is open, which alters water behavior dramatically. This creates moments of heightened risk, even though fewer people are present. How to share this information? From these seasonal maps, I began thinking, how do I share this? This led to a concept of an interactive digital safety map, a tool that communicates local knowledge in a clear, accessible way. Anyone arriving at the beach could understand rip currents, visibility limitations, safety zones, and danger areas before entering the water. The chaos map. From this broader mapping, I scaled in to look specifically at Surfers Corner, this time through the lens of a chaos map. Chaos here doesn't mean disorder in a negative sense. It simply reflects the reality of many people using the same space in different ways at the same time. Within this everyday chaos, it becomes surprisingly easy for harmful or dangerous situations to go unnoticed. A struggle in the water, a person collapsing, or someone drifting into a rip current can be hidden in plain sight. This mapping helped me understand how vulnerability can occur even in highly populated spaces. I extended the chaos map further down the beach towards the raised promenade. Here, an interesting contrast appears. In some areas are full of activity while others remain strangely unused. These unused areas are often correlate with poor surveillance, either due to sand dunes, building shadows, or simply a lack of visibility. To deepen my understanding of beach safety, I interviewed an NSRI volunteer. They shared critical insights. For example, winter is particularly dangerous, not only because the lifeguards aren't present, but because the topography of the beach itself changes. The sand shifts and the water becomes deeper more quickly. This reinforced the need for all year-round surveillance and responsive infrastructure. They also spoke about the current base at Strandfontein. The station has a long history of break-ins and sits in an isolated and poorly surveyed area. I originally considered moving the base closer to the civic centre, but they explained this would create launch risks because of the number of swimmers. This reshaped my thinking completely. The cameras. Then I learned about the existing NSRI camera network across the Western Cape. Cameras are strategically placed at dangerous beaches and all feed to a single control room. In this one case they showed me, they spotted a drowning child on the camera feed and immediately alerted the lifeguard on duty, resulting in a successful rescue. This demonstrated the real, measurable impact of enhanced visibility. We entered the interview by discussing the future. One of their biggest needs is potentially for drone equipment, to expand search capacity quickly. Drones allow rescues to begin before a team is even launched, which can be life-saving and double the search area. Movement infrastructure. Glencairn. After the interview, I shifted the focus towards a pedestrian movement network between Simonstown and Muizenberg. Glencairn, coming from Simonstown, has a relatively small but well-used walkway that directly engages with the coastline. Kalk Bay. In Kalk Bay, there are two pathways. One is squeezed between the road and the railway, and the other one is more detached and holds its own as a distinct piece of infrastructure. It functions independently and tracks consistent pedestrian use. Muizenberg. By contrast, Muizenberg has the largest and raised pedestrian walkway along this stretch, but surprisingly, it is vastly underutilized in comparison, despite its scale and potential. This disconnection became a key point of my analysis. The chaos section. To illustrate this, I developed a chaos section through Muizenberg's raised walkway. It highlights the multitude of users around the space and shows how the bridgeway is physically present but not socially connected. My conclusion is that the bridgeway simply ends abruptly in the dunes, offering no real continuation or purpose. It lacks lighting, clear destination points, and suffers a large unwatched areas. This makes it uninviting and even unsafe. Towards a design intervention. Connection. My proposal begins by reconnecting the pedestrian system. I propose continuing the pathway by creating defined ramps that curve up onto the existing bridge and then back down towards the road, allowing the route to flow naturally. Manipulation. Before designing the building, I explored ways of manipulating the site itself. For example, the beach huts, which currently block key sight lines. They could be shifted under the bridge. I also explored how to reconnect the new pathway directly to the beach. Intervention. The intervention sits at the point where the walkway currently terminates. By placing a new structure here, it becomes an attractor, a node that draws people in and encourages continued movement along the route. Continuation. The pathway then continues towards Strandfontein. It diverts left to the road to protect the dune ecosystem, and then follows along the road all the way to Strandfontein and beyond. This creates a continuous movement corridor for walkers, runners, cyclists from Simonstown all the way to Strandfontein. Plan design. The angle and direction of the new route are defined by a natural curve. I use the structural footprint of the existing bridge and staircase as a starting point, with new ramps leading down to the beach. The form of the building responds to the environmental forces. The curved facade shields against strong southeasterly winds, and the internal pathway offers relief from the sun, wind, and distance for commuters, as well as the shape allows for sightlines. Intervention rules during the design process. My guiding rules were simple. Design from the existing bridge because of its structural magnitude. The building's function is a rescue drone base, meaning the roof acts as an angled slingshot launch system. This determined much of the form. Model and ribs. My initial model explored a frame system that could create this angled roof. It became clear that it was too small and didn't engage with the ground properly, but it introduced the idea of using standardized ribs as repeating structural elements. At the base, a glass beach facade provided an omnidirectional view over the bay. This isn't about surveillance as control, it is about visibility as reassurance. People on the beach can look towards the building and understand that help is present. Structural model. I then explored a precast system of recognizable rib elements. This grounded the scale of the building and tied it to an architectural language of repetition and rhythm. The plans. The ground floor plan. The ground floor is designed as a semi-submerged basement. Because the sands shift continuously, the basement is expected to remain partially buried. The function is to store drones, wings, and a battery charging system. The surrounding sands act as a thermal mass to protect the batteries, with a closed-loop water cooling system fed from the flame. The first floor plan. The first floor aligns with the top of the bridge. The building splits into two parts, with the pathway weaving through the center. On the one side is an exhibition and shop space, inviting the public to learn about the NSRI's work. There is also a small rest area for volunteers. Connected to this is a bicycle shop, serving as both a rental and repair center to support movement along the route. On the other side is a small ice cream cafe and water point, offering shade and rest to commuters. A ramp descends toward the beach, with carefully defined walkways weaving through the dune rehabilitation nets. Second floor plan. The second floor houses drone operations. This includes control rooms with a clear south-facing views of the bay, meeting space and a balcony. A raised walkway leads to the top of the cafe building, where a recovery platform allows drones to be safely retrieved after missions. Sections. Section AA. This section shows how the structure lightly touches the ground and how ribs can also act as viewing platforms. It also illustrates the drone recovery system, a bungee suspended between the superstructure that catches and lowers the drones after landing. The 1 to 50 technical section reveals the structural logic, a precast concrete paired with a central concrete spine wall. The CMU basement wall that corbels out to form a rib angle. The GMS curtain wall and roof system to withstand corrosion. The launch system uses steel trackways with bungees, similar to the zipline drone project used successfully in Rwanda. Section BB. Here, the surveillance cones become clear. Cameras, drones, and human eyes cover the different angles of the beach, ensuring full visibility. The cafe windows look towards the dunes, reinforcing these layers of watchfulness. Elevation. The beach elevation shows the scale of the building and multiple uses of the ribs. Flagpoles, solar panel supports, shaded walkway elements, and viewing platforms. Each rib is used intentionally and differently. The perspective demonstrates the renewed movement of the pathway. Inspired by the chaos map, the beach becomes a place with no hidden points. Everything is visible, safe, and connected. Drone operations remain entirely safe for beachgoers. A night from Kalk Bay. This final visual illustrates the concept of safety points along the entire route. Each rib glows with embedded green lighting, signaling guidance and safety. Some ribs hold rescue buoys, others support lifeguard steps. These elements act as small acupunctures, local interventions that together repair and strengthen the larger coastal movement system. They create recognizable, continuous language of safety along the False Bay coastline. Thank you.